all, and welcome to this lesson. In this lesson, we will be considering balancing chemical equations. And I want to begin with this equation. Okay, so we have Al, aluminum, plus hydrochloric acid, that's HCl, produces, we have aluminum chloride, AlCl3, plus hydrogen. And so the first question is this balanced? And if it's not balanced, then how do we go ahead and balancing it out? Okay, so we're gonna construct a table. Okay, and in this table we have the reactants. All right, we have the reactants, and on the other side we have the products. Okay, and if we notice carefully, we have Al on this side, and Al, we only have one for Al. It's only one. For Al on this side, we only have one, so that's good. Okay, we only have one. For hydrogen on this side, we have one. For hydrogen on this side, there's two, right? So hydrogen, there's two. For Cl, chloride on this side, for Cl on this side, we have, on the reactant side, we have one. And for Cl on this side, we have three. And so clearly at this stage, we can say that there is an imbalance, all right? So the chemical equation is not balanced because we have 3 for Cl on the product side, but we only have 1 for Cl on the reactant side. We have 2 for hydrogen on the product side, and we only have 1 for hydrogen on the reactant side. So 2 on the product side, but only 1 on the reactant side. So clearly there's an imbalance here. So the chemical equation is not balanced. But we can balance it, and that's going to be our work right now. How are we going to go about balancing this chemical equation? And we know it's going to be balanced if for all the elements that we have on the reactants, we have the same thing on the products. Okay, so let's begin with Al. Notice that for Al aluminum, there's only one, so we don't have to change that. At least let's see. At least currently there's no problem there. We may have to change it, but let's see with the problem. So let's see how we're gonna solve the problem. Notice carefully. Notice carefully. I want to deal with I want to deal with Cl, right? I want to deal with that because here we have three, and here we only have one, and here we have three, but here we only have one, and so this is 3 on this side. And so we need to do is, in order to get this to be 3, we can just place a 3 here. Okay, we can just place a 3 here. And let's see if that works. If we place a 3 there, then that means we have both Cl is 3. Okay, but then let's see if that poses a problem. Well, it does pose a problem because here we have 3 Cl on the reactant side, but on the product side we only have 2. So here we have 3, but on the product side we only have 2. So the question is, what can we multiply by 2 to give us 3? Okay, so what can we multiply by 2? And what can we multiply by 2 to give us 3? And so since we don't know what the answer is yet, let's use a question mark. And we can always use a letter to represent a number that we don't know. So let's use P. So this is going to be 2P times, 2P equals 3. Divide both sides by 2. And so we have that P equals to 3 over 2. So if we multiply 3, so if we multiply 2 by 3 over 2, and 3 over 2 is simply 1.5. If we multiply 2 by 1.5, the answer is 2. No. The answer is 3. And how is that the case? Well, because let's actually do it. Okay, so it's going to be 3. Reason why we know is because we have 2 times 3. 1.5 is 3 over 2. Okay, this 2 and that 2 cancels out, leaving us with just the 3. Okay, so 2 times 1.5 is definitely 3. And so with that in mind, let's go back to our equation. If we place here 1.5, it's going to be 1.5, or you can even put 3 over 2, whatever. If we do that, then on this side we would have 3 for hydrogen, and on this side we also have 3 for hydrogen. But remember, we do not like it when we have decimals or fractions in our chemical equation. And so we're going to do is we're going to multiply the entire equation by 2. Okay, we're going to multiply the entire equation by 2. And the reason why we're going to multiply by 2 is because we know that instead of this 1.5, what this actually is this is 3 over 2. Okay, and we notice that the 2 is actually the denominator. And so we need to get rid of that denominator so that we just be dealing with whole numbers. So the denominator is 2, so we're going to multiply everything, okay, by 2. And so what is 2 and AL? And that's going to be 2. Sorry, let's erase this. That's going to be 2 AL. What is 2 times 3? Well, that's going to be 6 HCl. What is 2 times 1? That's going to be simply 2 AlCl3. And what is 2 times 3 over 2? Well, that's definitely just 3H2. And so let's see if this equation is balanced. We have the reactants and we have the products. Now for the reactants, notice that for Al we have 2. So Al is 2. For here we have Al being 2 as well. So Al is 2. Aluminum, we have 2 of them. Now let's look at hydrogen. So hydrogen, on this side we have 6 hydrogen. All right, let's look at our product side. For our product side we have 3 times 2, and 3 times 2 is definitely 6, so hydrogen is fine. So hydrogen is going to be 6. Now for our chlorine, now for Cl rather, we have Cl here. This 6 accounts for this 6 also is referring to this Cl as well. So the Cl, we have 6 for Cl here. And for Cl on this side, sorry, let's write that properly. And for Cl on this side, we have, let's see, well, 2 times 3 is 6. This 2 times 3 is 6, so we have 6 for the Cl. And so that means that our chemical equation is definitely balanced, right? That means that our chemical equation is definitely balanced. We have 2 for Al, that's just correct, okay, and 2 for Al. We have 6 for hydrogen, 3 times 2 is 6, and for chlorine, we have 6 on this side, and for chlorine, we have 2 times 3, which is also 6. So the correct answer is this equation. That's going to be our balance equation right there. Okay, so let's do another one. let's do another one. So let's say, for example, we had, let's say, for example, we had GA. Okay, so we say we had GA. Sorry, let's make that smaller. So we say we had GA. So let's make it more closer. So let's say we had GA plus copper Cu, and let's say we have that with Br2, and that produces Ga Br2, sorry, Br3 plus Cu. Okay. So first of all, let's determine if this equation is balanced or not. Okay. Is it balanced? Is it chemically balanced or is it chemically imbalanced? Let's go and we break it down into the reactants side, and we have the products side. So we reactants and products. Okay. For Ga, we only have one. For Ga on this side, we only have one. So that's good. For Cu, we have one on this side, and for Cu here, we also have one. For Br, we have two, but for Br here, we have three. So there lies the problem. There lies the problem. These two supposed to be the same number, but they are different. And so we need to figure out how we are going to balance this. Okay, so let us consider it. Okay. Did we erase all that ink from that side? Or no? Okay. Right, so let's consider it. So we have Ga plus Cu Br2, that produces Ga Br2 Br3 rather, plus Cu. Okay, so how are we going to balance this thing out? So we have reactants and we have products. Okay, so how are we going to balance this out? Well, the problem is we have two here and we have three here. Okay, and so what if we can multiply this by 3? We can multiply this by 2. The reason why is because if you multiply this by 3, this will be 3 times 2, which is 6. And if you multiply this by 2, it'll be 2 times 3, which gives us 6. And so let's do that. So let's multiply this by 3, let's multiply this by 2. And if we do that, let's deal with the BR first. The BR would be 3 times 2, which is 6. And on the product side, it's going to be 2 times 3, which is also 6. Okay, that's neat. What about our copper? So our copper here on the reactant side is 3, but here on the product side it's 1. So we need to insert a 3 here. So it's going to be Cu, which is 3. And finally, for Ga, it's 2 on this side. For Ga here, it's only 1, so we need to place a 2 here. So Ga is going to be 2 on the reactants, and on the product side, it is also 2. And so there you have it. Our equation is balanced. 2 Ga plus 3 Cu Br2 produces 2 Ga Br3 plus 3Cu. So hopefully that helps. I'll see you in another video.